My name is Dr. Fuller. I would like to introduce you to the mathematical world around you. Today, let's examine multistep equations. Equations are two expressions joined by an equal sign. Remember, in algebra, the equal sign means that the equation is balanced. The expressions on each side of the equal sign have the exact same value. This also means when we manipulate an equation, the same thing must be done to both expressions to maintain balance. The goal of manipulating your equation is to isolate the variable, which means getting the variable alone on one side of the equal sign. We manipulate equations by using algebraic properties of equality. We start with one-step equations when we first learn to solve equations. These equations require one mathematical operation or step to isolate the variable. Next, we moved to two-step equations. These usually involve a variable being multiplied or divided by a value and a constant added or subtracted. Because two values are attached to the variable, two steps are required to isolate the variable. First, remove the attached constant by either adding or subtracting. Next, use multiplication or division to remove the coefficient with the variable. When we move beyond two steps, it is best to think. No, think is not a strategy or an acronym. Think means precisely that. Think about how you would solve the equation if you knew the value of the variable. Use that information to help you undo the operations to isolate the variable. Let's look at an example of this strategy. Think about how to solve this problem using the order of operations if you know the value of x. I could distribute the 3 across the terms inside the parentheses to begin with. But for this example, I deal with the 2x plus 5 in the parentheses first, since parentheses are first in the order of operations. First, multiply by 2. Second, add the 5. This takes care of parentheses, and there are no exponents. I move on to multiply and divide. So third, multiply by 3. This means the last thing we need to do is add 1. Now I work backward through this list of terms to undo the values attached to the variable and isolate the variable. The last thing on our list was to add 1. To remove the 1 from the expression on the left, I must subtract it or add a negative 1. The addition property of equality states that we may add any value to both sides of an equation to maintain balance. Therefore, I add a negative 1 to both expressions. Then I multiplied by 3. To remove the coefficient 3 from the expression on the left, I must divide by 3. The division property of equality states that we may divide both sides of an equation by the same number, except for 0, to maintain equality. Thus, I divide both the left and right by 3. I am left with the expression 2x plus 5 on the left and 15 on the right. Before I multiplied by 3, I simplified the expression inside the parentheses by dealing with the plus 5. To remove the 5, I may subtract it from both sides of the equation using the subtraction property of equality. And at the start, I completed the multiplication by 2 first. To remove the 2, I use the division property of equality and divide both sides of the equation by 2. After working backward through the list of operations, I isolated the variable. If you are unsure where to begin and all of your variables are on one side of the equal sign, this strategy is efficient and works well. Suppose we know how to solve a problem using numbers. In that case, we should be able to examine how values are attached to the variable to isolate it. Always remember to take a moment to check your equations. Substitute your answer back into the equation for all copies of the variable. Then simplify. If the left and right sides are the same, your solution should be correct. The second example has a variable on both sides of the equation. Since my goal is to isolate the variable, I need to move all copies of the variable I am trying to isolate to one side of the equation. I may need to expand using the distributive property of multiplication over addition and combine like terms on both sides before moving the variable to one side. After distributing the -3 across the parentheses, combine like terms on the left. There are no terms to combine on the right. Select a side to have your variable and use opposite operations to move the variable to one side. A variable can only be removed from one side by adding or subtracting it. At this point, you should have a two-step equation. Remove the constant by adding 99 to both expressions. To isolate the variable, remove the coefficient by dividing both sides by 8. When solving multi-step equations, we must think about what we are doing to both expressions. The terms in the equation will dictate the best ways to isolate the variable. As equations become more complex, the best thing to do is think. Think about what is happening to each side of the equation before you start to solve. In my mathematical world, I have one little problem. I play a game where I can purchase the game currency for real money. The typical conversion rate for changing dollars to game credits is given by the following expression. The amount of money you spend plus 20. That quantity is multiplied by 50, then divided by 4. An event is going on where a bonus of 1/10 of the money you spent is added as credits. I have 1,346 and 20 hundredths credits. The equation represents this conversion where X is dollars. How much is that in real money? I found an avatar upgrade for 303 and 55 hundredths credits. How much is that in dollars? A friend offers to trade 600 game credits in exchange for a $25 coffee card. Is that a good trade in terms of value? I bought 8 superpower packs because I had a coupon for 75 credits off each one. I spent 955 and 60 hundredths credits total. How much was each superpower pack before the discount? There is a new game I want for 900 credits in this gaming system. How many credits do I have left? And how much money do I need to spend in order to have 900 credits? Take a look and you will see a mathematical world around you filled with equations. Complex equations often appear in jobs in math and science-based fields like finance and engineering. But multi-step equations are useful in other areas. Remember, being able to manipulate equations is a tool, but the skills of thinking logically about what is happening and reasoning to work backwards can be applied in many more ways.